In my last video, I had written the code for sliding window. Okay, there was a little bit mistake here. Instead of window size as 4, we have to write window initial size, window init. So we have to initialize it to 4. So what it will do, it will send one packet. If the acknowledgement is received, it will directly send 4 packets. So sliding windows, it will send 4 packets from the beginning itself. Okay, so let us see, is it working? So first it will send one packet. If the acknowledgement is received for one packet, it will keep on sending 4 packets. So maximum we had set the window size as 4, so it should keep on sending 4 packets. So it has received the acknowledgement, so it should send 4 packets. Okay, so starting it, the old program, it was sending 1 to 4, so that's a wrong. We have to set window initial size. Okay, so now it is sending 4 packets and receiving acknowledgement for 4 packets. So this is all about the sliding window. Now let us go to the next program, that is Ethernet LAN. If you see the question of Ethernet LAN, we have to create multiple nodes with multiple traffic. Multiple traffic means we have to create more than one source node. So data should be sent from more than one source node. Traffic should be coming from more than one node. Okay, and we have to plot the congestion window. Okay, the X graph is for congestion window. We should plot that. Okay, consider there is a LAN connection. LAN means all of the computer will be connected. Okay, with a single cable. If you see the diagram, there are 5 nodes N0 to N4. All these N0 to N4 nodes are connected to the same LAN network. But there is another node, that is N5, which is not connected to the LAN, which is present somewhere else. Now we have to connect this LAN to that separate node. Okay. So I'll be making node N0 has source 1, and this N5, which is present in the separate area, that has destination 1. So I should send data from node N0 to N5. Okay, from source 1 to destination 1. Since they have asked, we have to make multiple nodes and multiple traffics, I am creating source 2 and destination 2, that is N2 N3. So N2 will send data to N3. I am making them nearby. Okay, so our main task is to design this system. Okay, so data should be sent from source 1 to destination 1 and source 2 to destination 2, since it is mentioned in the question. Next we have to plot the congestion window. Okay, we have to plot the congestion window. Okay, so this is the things we need to do. Another thing is, for Ethernet LAN we have to set two variables, that is local link layer and MAC link layer. So these two are very important. We have to set them to use the Ethernet LAN. Okay, we have to set them also in the program. So come, let's start. Hello everyone, my name is Mankan Sadati, and today we are going to learn how to simulate Ethernet LAN using NS2 software. So let me open the text editor and start typing the code. So I have opened the text editor. First we have to write the 10 steps which we need to follow. The first step which we need to follow is creation of the simulation object. After creating the simulation object, the next step we need to do is we have to create an animation file. So animation file is important because that is the one which will show us the animation at the end. So after animation file we have to create nodes, and to link these nodes we have to create the links. So after creating the links we have to create the agents. So we have to make the agents for those nodes. After making the agents we have to connect those agents. So next is the connecting those agents. Next we have to make application for those agents which we have created, creating the application. Next we have to create the time allotment, at what time it should run. So next is the creation of time allotment. So after time allotment we have to call the finish procedure at the last. So next is the calling of the finish procedure or creating of the finish procedure. After calling of the finish procedure, the last step is running the simulator. So these are the 10 steps which we need to follow. Now let us start typing the code for each and every step. So before that, let us save this file. So I am saving it as the name Ethernet LAN moneytesla.tcl. So I'll be saving it as Ethernet LAN moneytesla.tcl and click on save. You can give any name here, as I have given my name. Click on save. So after saving, it will be highlighted because the editor identifies that it is a TCL file. Next, first is creation of the simulation object. For that we have to use the command, that is set. Give any name for the object, that is NS. You can give any name, it is called object name. Next, keyword new. Then the simulator, we have to create a simulator. So new simulator. The next step is creation of the animation file. So before creating an animation file, we have to create a trace file. So let us create that. We have to use the command set, then give any name. I am giving testf, that is trace file. Open bracket, then open name of the file which you want to save as lab3.tr. Then give it the right permission. So in next line we have to trace them. So $ns trace all $tf. It will trace, that is copy all the data of the NS2 simulator to the NS object to the TF file. Okay, so this is the command. So it will trace all the data to TF. We have given the write permission, so it will write the data to TF. Next is creation of the animation file. So set NF, open, give any name here. I'll give giving it as lab3.nam. I'll be giving it the write permission. Next we have to trace $ns. Here we have to write nam trace all. We are tracing the animation file, so nam trace all. Then give the $nf. I hope you got it. Above I am just creating a trace file tf. So it will be tracing data of ns. So it has different parameters that we have to trace, that is congestion window. All the parameters will be stored in tf. Here I am tracing the animation data record for animation file. So nam file means animation file. Okay, the last animation which we see, if you execute that nam file, that is lab3.nam, the animation will run. Next is creation of the nodes. Let us create nodes. For Ethernet LAN, we have to create around 5 nodes, I have told. So let's create one by one. First, let us create the node N0. So set N0 $ns node. So we have created the first node. We have to give it a color and also a label. Let us create $N0 color. Let us give it as magenta, that is violet. Then we have to label. Let us make node N0 as the source one. So we have multiple source in Ethernet LAN. Let us create source 1 as the N0. Label N0 as source 1. Next I am going to create node 2, that is N1. Set N1 $ns node. This will be just a node in the LAN. Next I am creating third node, that is N2 $ns node. So this I'll make it as second source. Okay, we have to use multiple source and multiple destination in LAN. So this will be our second source. Let us write $ns color. Let us make it as also magenta. So I'll be identifying two source with the color magenta. Okay, next I am going to label it as $n2 label. Let us make it as source 2, src2. So we have created two sources. Okay, next we have to create two destination. Okay, let us create third node, that is set n3 $ns node. So this will be the third node. Let us make it as the destination. Okay, let us make it as destination one. So here we have to write $n3 and we have to give it a color. So for destination, let us give it a blue color. Okay, to differentiate from source, let us give it as a blue. Next $n3, we have to label it as destination 2. As I told in the diagram, we are creating source 2 and destination 2 closer to each other, but source 1 will be in the LAN and destination 1 will be in another LAN, so we have to connect it. Okay, so I will be creating destination 1 at the last. Okay, next n4 is just a node. N5, let us create it. N5 $ns node $n5. Let us color it as blue since it is a destination, and let us make it as destination 1. So this node 5 will be in the separate LAN. Okay, and source 1 is at another LAN, so we have to connect them and communicate them. Okay, $n5 label it as destination 1. So we have created the nodes. Next we have to create a link. Now N0, N1, N2, N3, N4, all the four nodes are in the same LAN, but N5 is in another LAN, so we have to write two links. First let us copy this comment and write the links. So I will be pasting here. So first is creation of link, that is let us make a LAN. Okay, LAN connection is between all the four nodes. Let us write $ns make LAN all the nodes, that is N0, N1, N2, N3, N4. All these 5 nodes will be in the same LAN. So I am making a LAN connection between these 5 nodes. So this is N4. After this, what we have to do is we have to set the bandwidth, that is how much data it should be able to carry, that is 100 Mbps. So 100 Mbps is the bandwidth. Make M a capital. After that we have to write the delay or how much time it should take, that is 100 ms, 100 millisecond. Next we have to write the logical link layer. I had said there are two layers, logical link layer and MAC layer. So logical link layer is connect a LAN to another external node. So logical link layer I am writing LL. Then we have to set the queue, like which queue we are using. We are using queue drop tail. So after that we have to write the MAC protocol. So which MAC protocol it is using. So MAC / 802_3. This is the MAC protocol which we are using for the Ethernet LAN. So after setting this, next we have to create a link between the N4 node and the N5 node. So N4 node is present in the LAN and N5 is present in separate LAN. We have to connect them. Okay, we have to connect these separate. So I am creating a duplex link between these N4 and N5. Next, I'll be setting the bandwidth 1 MB. Then I'll be setting time as 1 ms, then drop tail will be the queue type. Okay, these are the parameters which we need to set. So after creating the link between LAN and the next node, that is N5 node, next we have to do is we have to make agents. So making agents will be the next part. Set TCP0 as new, it is a TCP agent, so agent slash TCP. Next we have to do is we have to attach it. So $ns attach agent TCP0 to node N0. So we are connecting it to N0. So $N0 $TCP, we are connecting these two. After that we have to connect them. So what I'll be doing, making the agents and connecting the agents. Let me do it in the same step. So after attaching the agent, next we have to set sync new agent slash TCP sync. Now I have written it as sync 5 because we are sending from N0 to node 5. So receiver will be N5. So sync is for sync 5, that is node 5 sync 5. So right, $N5 sync 5. Okay, for node 5 I have attached the sync 5. Again next we have to connect them. So $ns connect TCP0 to sync 5. So we have connected. Okay, we had made the connection between source and the destination. Next we have to do same for source 2 and destination 2. This is for source 1 and destination. Next for source 2 and destination 2. Let's make the few changes is we are making it as TCP2. Next change the name for the node. So here I'll be using node 2 and TCP2. Next sync I should also change. So here I'll be using another sync, that is sync 3, and because I have connected to the node 3, so N3 has sync 3, N3 is the receiver. Next I have to connect them, so I'll be connecting TCP2 and sync 3. Okay, after that is creation of application. So we have to create two application because we are using two source and destination, right? So first FTP0, this is for TCP0. Let's create. So FTP0 attach agent, we have to attach which TCP0, so $TCP0. So after that we have to set few parameters also, that is we have to set the parameters like packet size, how much packet it should be able to send. Let me set it as 500. And next interval, for how much interval it should send, after how many intervals it should send that packets. Okay, so set time interval, I'll be rating 0.001. For every 0.001 second it will be sending the packets. So I'll be copy pasting this and I'll be rating the same for source 2 and destination 2. Okay, we are communicating between two of them. Okay. So this first one is for this, so and this second application is for this second one. Okay, let me make changes. After creating application layer, the question given to us is we have to plot the congestion window. Okay, we have used two source, two destination, so we'll have to plot two graphs. There will be two congestion window. Okay, so I'll be creating a file. So file1.tr, it will trace the congestion window data for the first source and destination. I'll be creating file 2 for second source and destination congestion window. We'll be using the these two tr files. We'll be extracting the congestion window data and plotting it. Okay, so let me create. I have created file 1. I have opened the file 1 tr and given it write permission. So I'll be attaching it to TCP0. Okay, congestion window size will be for sender nodes, right? So I'll be connecting it to TCP0. Next I have to create same. So I'll be creating file 2, open file2.tr, then I'll be attaching it to second sender, second source, that is TCP1. Okay, I hope you got it. So this file 1 and file 2, what will it do? It will trace all the data of the sender nodes, and we have to extract the congestion window from data. So there will be many data present. Okay, we have to extract the congestion window from this file 1 and file 2. That will be doing in the next part in the awk file. Okay, so I have created two files to trace the both the senders because we need to plot the congestion window, and congestion window is present in these file 1 and file 2 tr. After that we have to set the trace where trace cwind as true. By writing these two, it will be true. It will enable the congestion window to trace. Okay, for TCP0 and TCP1. So I'll be able to trace them and store them in file 1 and file 2. Next is creation of finish procedure. Before time allotment, we have to create finish procedure. I'll explain why. So first let us create the finish procedure. Okay, let me copy this and type it above. Why we are creating finish procedure before time allotment, I'll explain. Wait a minute, let me paste this. So we have to create the finish procedure. So let me copy this. Okay, next we have to do time allotment. Let me copy this creating finish procedure. After copying, let's write the code for this. So writing procedure starts with proc finish. So open bracket, close bracket, then again open bracket. All these three should be in the same line, and also same space should be maintained because it is space sensitive. After that, I'll be creating global variables, that is NS, NFTF. I'll be setting them as global. Then flush trace means it will trace all the files. It will enable to traces all the files. Next, close the files which we had created, that is the NF file and the trace file. Next we have to run the animation. For running the animation we have to execute the NAM file as I told previously. So let us execute, that is exec. We have to execute NAM file, that is lab3.nam. Okay, and we have to exit. So after tracing we have to exit. So finish procedure is done. Next is creation of time allotment. So let us create. Let me copy this and paste here and write the code for time allotment. Okay. The thing is time allotment you can give any time and you can run any time. Okay. You can give any specified value. It is not mandatory that you should give the values which I have mentioned here. Okay. So you can start whenever the you want. So you can start whenever you want. So let me start. $ns at will be used to mention the time. Okay, at 0.1 ftp 0 start. So I'll be starting the ftp 0 application. At 5.0, that is $ns at 5.0, I'll be stopping this ftp. Okay, ftp 0. So you can give any time here. It's not that I should give 0.15. Whenever you want you can start the application or stop the application. So according to the time given by you, it will start or stop. So I'll be writing the time for this. So you can randomly mention any time for as your convenience. It is not mandatory. So I'll be completing this and let us move to the next code. The last line of the time allotment is we'll be calling the finish procedure. So $ns at end at that is 16. Let us call the finish procedure because we are calling the finish procedure. It should be declared first only, right? So we have to write the finish procedure first, then we have to call it. So I have written the finish procedure first. Okay, then we are calling the finish procedure. So it will execute the animation file and it will exit. Next last step is running the simulator. So let me paste this. So run simulator, that is $ns run. So this is the code for Ethernet LAN. I hope you understood. Now let me run this. So since I have typed it, there will be so many errors. So I have not cleared any errors. I will be helping you to solve the errors, like how to identify and how to solve them. So let me run this. $ns Ethernet LAN money tesla.tcl. There will be many errors. Let us see how to debug them. So here it is showing there is a error at line 19. So also it's showing where is the error. Okay, there set tf. So let us open the file and see at line 19. So here I'll be keeping the terminal at the right side so that we can see. So here line 19. So what is the error? We have to give the space there. Okay, let us run it now. Let us save it and run it. Go to the terminal. Okay, again it's showing at 23. Again we have not given the space. So it is space sensitive. We have to give space at the correct position in NS2. Okay, just run. Again error. What's the error? Again space we have. Okay, there is a problem. It's not identifying. Okay, it is N0 not NO. I had given NO. Let's say run. Again it's okay. Here N5 we have to give space in front of the N5 before the bracket. Again save. Let me run. So we have to see the line number and we have to try to decode what should be there. Okay, next here there is a problem. Let us see what's the problem. Okay, see, so showing there is a error at line 64. So let me see line 64. Where is the error? So in the line 64 there is a, okay, here I have to give space. Okay, now let me run. Here also I'll be giving the space all the place. Let me see Okay, I think that's it. Now let me run the code. Open the terminal and let me run it. Okay, it's showing error. What? Oh, sync3, no such variable. So I had not declared sync3, I guess. Let me see. What's the problem? Okay, here it's not sync5. It should be sync3. Like I copy pasted, I forgot to change. So it should be sync3. So it was not identifying sync3. We did not create sync3. We had created by sync5 only. So now let me run this. Again, it's showing error. Okay, it's T. I have written TP0. It should be TCP0. TCP0. Now let me run. I hope it doesn't show any errors. Okay, let me open the terminal in the new window. Now let me run. Okay, finally it's running. So this is the Ethernet line. So let me edit this. Here you can see this node N3, then N0, next N2 and N4. This is N1 and N4. All are connected to the same LAN and N5 is separate. Okay, you can see. Let me run this. Here see. Source 1 should send data to destination 1. So source 1 will send the data to LAN. LAN means it will go to everywhere. Then from it will go to node 4. From there it will go to destination. You can see that's going. Next, this source 2 is sending data only to the destination 2. You can see data from source 2 is going only to the destination 2. Okay, from source 1 it is going to the whole LAN, and from N4 node it is going to the external node. Okay, this is what how the Ethernet LAN works. I hope you got it. Now we have to plot the graph for this. Okay, let me exit this. Open the terminal and type the commands. So here I will be typing gedit lab3.tr. So this will open the trace file. Okay, let me see. So this is what the trace file. There are around 5 to 6 values here. Okay, 5 to 6 columns. Okay, okay, let me close this. Next, let me open the file1.tr. Okay, so let me write gedit file1.tr. Okay, we have to plot graph for file1.tr and file2.tr. You can see there are 7 fields. We just need the first column and the 7th column. Okay, we need the time value and the CWND value. Using these two we have to plot. We don't need the rest of them. The center data is not useful for us. We have to remove them. Okay, let's see how to remove them. So now we need only first column and the 7th column. That is the time and the CWND value to plot. So let me open a new file, that is ethernet.awk file. Now let me write the code here. Okay, it's very easy. First we have to write the begin and the end command. So in that we have to write the code. So let me write begin. Okay, if if there is CWND present in that file. Okay, if $6. So if the 6th column is CWND, to check. Okay, if 6th line is CWND. So printing is same as C programming here. So we have to write the format specifier, that is %f. /t means it will give space of tab, then %f /t again tab space. /n means it will go to next line, comma $1 and $7. Okay, it will be just printing the first line and the 7th line which we require. The first line is the time and the last line is the CWND value. Okay, next we have to end this. So I am writing the end. Okay, this is what the AWK file looks like. What will it do? It will just print the first and the last line. So let me run this. Okay, gedit. Let me run the AWK file first. Okay. So now what we have to do is we have to take the file tr file, run the awk file, and just extract the first and the 7th column. So awk -f ethernet.awk, the code is written here to extract first and 7th line. From where we have to extract? From the file1.tr, and I'm using greater than a. So this means it will copy all the data, that is first and the last line, to a new file called a. So you can see a file is created there. Next, same for the file2.tr. So what will it do? It will store the first and the 7th column in the A, and first and 7th column of file 2 in the B. So let me see. See here, this is the A file. You can see only 2 columns are there. That is the first column and the 7th column which we needed. Also for B also you can see first and 7th column are required. Now we have to plot these two. Okay. We needed this value to for plotting, so we can plot this. So for plotting we use a command called xgraph. So xgraph is used for plotting. So xgraph, write A and B. So it will plot the graph. Like I had installed Ubuntu in my virtual machine, so few of the features are not working. So you can run it in the original Ubuntu system and it will run. So this is all about Ethernet.